Stephen, you've been working on various antenna designs and configurations. Can you explain the safest ways to observe the generation of small electromagnetic pulses?
Certainly, Joanna. Observing the generation of electromagnetic pulses involves some inherent risks, but by following strict safety guidelines, we can minimize these risks. Ruth and Brian can elaborate on the essential precautions and guidelines for safe observation.
Ruth and Brian, could you walk us through the safety measures for observing electromagnetic pulses?
Absolutely. Here are the key safety precautions. Use minimum power levels necessary for your experiment. Higher power levels can increase the risk of injury or damage to equipment. Use personal protective equipment, PPE, such as eye protection and non-conductive gloves to protect yourself from potential radiation or electrical shock. Maintain a safe distance from the pulse generator and any associated antennas or probes. The intensity of an electromagnetic wave drops exponentially with distance, so keeping a safe distance can greatly reduce the risk of exposure. Use shielded rooms or enclosures to isolate the pulse generator and associated components from the surrounding environment. Shielding prevents stray electromagnetic radiation from escaping the enclosure and affecting personnel or equipment outside. Ensure all staff members involved in the experiment undergo proper training on safety procedures, operation of equipment, and emergency response. Establish an emergency response plan that includes instructions for evacuation, shutting down equipment, and summoning medical assistance if necessary. Regularly inspect the pulse generator and associated components for wear, damage, or defects that could lead to accidents or failures. Repair or replace damaged components immediately. Have a designated supervisor present during the experiment to ensure safety protocols are being followed and to address any emergencies that may arise. After completing the experiment, review the results and assess whether any safety procedures need to be adjusted or updated.
Brian, could you summarize the expert's insights on these safety measures?
The expert confirmed that Stephen's approach to safety precautions is thorough and well considered. Ensuring minimum power levels, using personal protective equipment, maintaining a safe distance, and employing shielding are essential steps. Proper training, regular inspections, and a robust emergency response plan are also critical for safe experimentation. Reviewing procedures after each experiment helps to continuously improve safety measures.
Stephen, your commitment to safety is commendable. How do you plan to implement these safety precautions in your experiments?
Implementing these safety precautions requires meticulous planning and strict adherence to guidelines. I plan to ensure that all equipment is regularly inspected, proper training is provided to everyone involved, and a detailed emergency response plan is in place. Safety is always the top priority.
Your dedication to maintaining a safe experimental environment is truly inspiring. Sharing your safety protocols and procedures not only helps you but also provides valuable guidance to others working with electromagnetic pulses.
In this 27th part of our series, we've explored the safest ways to observe the generation of small electromagnetic pulses, including essential safety precautions and guidelines. Stay tuned for the next part, where we will continue to explore potential defensive strategies and support systems for those affected by similar forms of harassment.
Stephen's story continues to highlight the relentless nature of technological harassment and the sophisticated strategies required to combat it. By continuing this series, we aim to provide a comprehensive understanding and foster a dialogue that can lead to meaningful change.